Why do we want DC? Good point. So, we want only the positive cycle of the wave, right? That's what we're trying to achieve there with that game. So we only get that positive cycle, the blue cycle. Why? Because we need a square wave to go from 0 to 1 only. We don't want the negative cycle, right? So we need to isolate the AC by using a half-wave rectifier. Which is that. It just allows the wave to go through and only the positive to come out. So that's the input, that's the output. And the negative cycle is just, it's not allowed through. Now what I'm wondering about, right, so you know bits and stuff, right? Yeah. What is a bit? Well, it's one bit of information. The easiest example is the Morse code, right? And the telegraph, because people were able to encode the entire alphabet with just the press of a button. So that's one bit, really. Yeah. Well, yeah, it just goes one and zero, right? Yeah, the Morse code. The telegraph has two types, I believe. There's one that's always on. The power line is always high, and you interrupt that signal with the push button. And I believe there's also another type, which is always off, right? But you have an active or powered button with the current going through it, so that buzzes it, bzz, bzz, right? Now I'm wondering, like, well, I was wondering about clocks with stopwatches as well. Like, when did they start? Yeah, when did they get started? I have no idea. And stopped. And also, was there ever a Morse code machine? Because I don't think like people were doing that all the time, you know. I think eventually there was probably like a wheel that could turn and maybe a program or something, you know. Like an early computer or something, you know. Yeah, maybe, yeah. So that's one bit. If you get TX and RX, which is transmit and receive, bidirectional communication, which is two-way, you can get 2 bits, right? Yeah. So one's going one way, one's going another way, and then that starts getting multiplied easily. So all you need is zeros and ones really for digital logic. I'm gonna get into that eventually. It's really complicated, right? Yeah. Yeah. Shift registers and everything. They just shift the register of that on a clock cycle, but you kind of need a clock, and you kind of need a push button, and you kind of need a half-wave rectifier to get zeros and ones. Yeah. And then eventually you get to a transistor, but like that's later, yeah. This is just a push button, right? And then you just clock that, and then eventually you're able to create a square wave that's needed for like communication and computers.